31.
31.
42, 46, 43.
Oh yeah, definitely 46.
I need to be on the right page. What page is it?
130.
Get it together, Stacy. Get it together. What'd you say, 31? 31 like we did yesterday?
The 1/2 and then bringing it around -1/2.
All right, well, let's do it. Nothing to it but to do it, right? Derivative of the top. What's the derivative of square root of x? 1/2 x to the -1/2. Right? That's derivative of the top times the bottom minus the top times derivative of the bottom, same thing, yes? Okay. All over, you don't understand which part? Oh, okay, thank you. All right. What happens here? 1/2. X to the -1/2 times x to the +1/2 gives you x to the 0, which is just 1, right? So this is just 1/2. So x to the -1/2 times x to the 1/2 would be x to the 0, which is just 1. So when this comes through, it's just 1/2.
Oh, it's because you
You add them. Correct. Yeah? Tell me when you're ready.
Oh, I do have one question. Do you use the one on the top first?
You have to do the derivative of the top first times the bottom minus. And order matters on this one because you're subtracting, not adding.
I was thinking about
So now this is going to be plus 1/2 x to the -1/2. Are y'all okay there? Minus, and I'm going to put this in parentheses since I'm subtracting all of this, and I'm going to take this and distribute this way. Again, this is the same thing. It just gives me 1/2, yes? Okay. Minus 1/2 x to the -1/2. All over. I don't have to do anything with this bottom. It's already completely factored. I can just leave it that way. All right, let's see what happens here. Some things. Say again, why'd I go it? And x to the 0 is what? 1. So you got 1/2 times x to the 0. Yeah. Because the square root of x is x to the 1/2. So if I do the derivative there, I bring that around 1/2 x, and then I subtract 1 from the exponent, which would be negative. So good? All right. Same, change everything. The 1/2s go away, yes? I got a half of an x to the -1/2 and another half of an x to the -1/2, which would give me a whole x to the -1/2, yes? 1 whole x -1/2 over square root of x plus 1 squared. If I want, I can move this down. That is the square root of x. This is the square root of x plus 1 squared. don't necessarily have to know.
So wait, and the bottom gets squared? So for the,
Yes?
oh, I thought you were like, somebody can throw it too.
Okay. I'll do 32 first since it comes first. Derivative. So this is just subtracting, so I can just do each one individually. It makes things infinitely easier, yes? This is the same thing as x to the 1/2. This is the same thing as x to the negative 1/2. If you write it that way, it'll make your life a lot easier.
So it's, over.
It's just a negative exponent. That's all it is. So this would be a 1/2 times 2, which is 1. And then subtract 1, I get negative 1/2. I bring this negative 1/2 around, so then I got two negatives, so we plus 1/2 x, and then subtract 1, negative 3 over 2. Okay, how did I get which one? Okay, so this is x over this is 1 over x to the 1/2, right? Oh. Okay, so bring it around and multiply, right? 2 times 1/2 is 1. And then subtract 1 from the exponent. Same thing here, bring it around and multiply, except for it's negative this time. So I got minus, this would be negative, this was minus negative 1/2, which is why it became plus. And then minus 1 would be negative 3 over 2. No, on that one, I think that's good. They very well could have, since they both have square roots, they may have, yeah, that's fine. Either way. Don't let the radicals intimidate you, because change them to an exponent and they make it a lot easier. Oh, 46, are y'all kidding?
Oh, this is that one.
All right, it says find dp dv. So this is like my y and my v is like my x. Those are my variables there. So hopefully n, r, t, n, b, and a are all constants. Let's see. A, I'm just going to come here and kind of see. This is a constant. B is a constant. N is a constant. Capital R is a constant. What does it say about T? What is T? It says in the beginning, gas in a cylinder is maintained at a constant temperature T. So that's a constant. We already said N was a constant. N was a constant. Everything is a constant except for the V. Right? So if I want to take the derivative, the very first fraction, derivative of the top, well, what's the derivative of a constant? Times the bottom, it doesn't matter because this is going to be 0, right? Minus the top times derivative of the bottom. What's the derivative of v with respect to v? If that was x, right? This is where, see, this bottom variable is matching this variable. So 1. What's the derivative of a constant here? 0. Over the bottom squared, b minus nb squared. And then I can do the second fraction the exact same way. Derivative of the top, of course, is 0 times the bottom. It doesn't matter because it's 0. Minus the top times derivative of the bottom. What's the derivative of v squared with respect to v? 2v. If this was x squared and I asked you to find d dx, what would you tell me it was? 2x. This is just dv of v squared. And the reason it's dv is because it told me in the beginning find dp dv.
So you just keep the NRT.
Well, we keep it, let me go ahead and square the bottom. We keep that when we need to keep it, yes, when it's just times the top. Where'd I get rid of it? Well, the derivative of this, because they're all constants, is 0. Derivative of a constant. Constant times a constant times a constant is a constant. And the derivative of a constant is 0. Right?
Like a number, like any number?
Any number. Right? So this is a constant altogether. This altogether is a constant, as is this. Because remember how it works? It's derivative of the top times the bottom minus the top as it's written times derivative of the bottom. So even if it's a constant, it needs to be included in there. All right, so now let's clean it up a bit. This is just going to be 1. This goes away, right? Oops, that minus is still there. So I got negative nRT over v minus nv squared minus, this is just 0. Here I've got minus a negative. I'm just going to make that plus. 2an squared v over v to the 4th. It looks way worse than what it is. That's the answer. You could technically take a v out. You don't have to. Welcome to calculus, where you can do a whole problem with no numbers instead of an answer. Oh. No, they're not entertaining. What else? Why are you looking like that, Robert? Glared at me. You just look like that? You just have a natural glare? M squared C over 2 minus M over 3. C is a positive constant. I'm just going to circle the constant. C is a positive constant. M is the amount of medicine absorbed in the blood. Reaction change in R is measured in millimeter. Reactions change in temperature. Find dr dm. M is going to be my variable just like X. R is like my Y, right? Whenever I do this. Okay, so then I only have one constant in there. I'm going to use product here. Derivative of the first times the second plus the first times derivative of the second. Derivative of a constant, 0. Derivative of m over 3. Y'all can do this. M over 3 is the same thing as 1/3 m. What's the derivative of that? 1/3, right? It's negative because of this negative. All right, m over 3 is the same thing as 1/3 m, yes? If you do, if I asked you what's the derivative of 2x with respect to x, what would you tell me it was? Where'd the x go? It went away, right? Because it's the derivative. It goes 1 power down. This one had an exponent of 1. It goes 1 power down. So when you multiply around, you get 1/3 m to the 0, which is this. Is it because it looked like this instead of written like 1/3 m? So 3. I might clean this up just a bit. If I distribute here, I get, the 2's would cancel, I get c over m minus 2m squared over 3. If I come here, I get 2mc. Oh, it's not over now. Let me write it down. 2mc over 2. So it's just mc. This one would be 2m squared over 3. This one would be m squared over 3, but negative. So I get mc minus, these are like terms, right? They're m squareds and they're both over 3, so I can combine them. Negative 3m squared over 3, which is isn't that nice how that works out? Yay! You don't like letters? What else on your homework? That's it? All right, I'll give you just find an equation for the tan line at the point 1, 2. Mark that go. Find an equation for the tan line at the point 1, 2. This is, I titled this Derivative Rules Tan Lines. It's the last day of derivative rules, if you want to call it that. Huh? Equation? You don't even have to do that anymore. You know the shortcut.
I don't know what you're talking about. That's finding the tan line?
Well, that's finding the slope of the tan line. That's what derivative is. Derivative is slope of the tan line. Bro, we say that every day.
I did not know that. That's not really true, but
Do you really?
yeah, 100%. I don't remember that. It's just 2 extra issues.
Oh, this would be a non-calculated problem. Sorry. That's why. But yes, you could if this was a calculator problem. Do y'all need me to walk you through this one? Yeah. That's okay. Some of y'all were looking going, I didn't even know where to start. That's why I want to make sure. Derivative of the top times the bottom. This is the derivative of the top times the bottom minus the top times derivative of the bottom. All over bottom squared. If you're a simplified kind of person first, you can go through and simplify this. If you are a plug-in just to get your answer, you're right. But if I find the derivative at 1, then what that is that's the slope of the tan line at the point 1, 2. Yeah. Right? So to find, remember, to write an equation, I need a point and a slope, right? I have a point, I need a slope. To find the slope, I find the derivative at that point. So I found the derivative here, now I'm going to plug in 1. What I was saying is if you like to plug in the beginning, and you wanted to get to this point and then just put a 1 in here for everything, you could have. I like to simplify first, yeah.
So this would be the IRA?
Yes. Oh, you got this first step?
Yeah, it's not. That's right. I thought you would do 1 minus.
What are y'all talking about right now? That's right. From the second to the third, I combine like terms.
I thought they were different.
So now I'm going to plug in 1, right? Because I want the slope when x is 1. So 2 times 1 squared minus 6 over 4 times 1 squared. You could if you wanted to. If you wanted to make this x squared minus 3 over 2x squared, you certainly could. You'd get the same thing. Negative 4 over 4, which is, that is my slope, yes? So I asked you to write the equation of the tan line at that point. Point I'm using is 1, 2. The slope is negative 1. So y minus 2, what goes next? Here's your x1, y1, and here's your slope. Not there, sorry. Here's your slope. So I'm still doing the same thing that I've been doing, I'm just using shortcuts to do it. Because it said the tan line at the point 1, 2. In that very beginning. Y1, X1. You're welcome. Let's do another. Yep. Let me ask you this while we're still in this problem. Thinking about this same equation, x squared plus 3 over 2x. Is there any place where the tangent line is horizontal? Well, bottom equal to 0 does what? Right. So what do I need to do to know if horizontal, set this equation to 0? That's going to tell me if I have horizontal asymptote. If I have horizontal tangents. Tangents being horizontal. Set the top equal to 0. Top of what? The derivative. Because the derivative is telling me the slope. I want to know where's the slope of the tan line 0, right? Horizontal. Y'all, we did this in the last chapter. Y'all are thinking too much about this. All right, horizontal tangents happen when the slope of the tan line equals 0. Yes? How do I find the slope of the tan line? We had a couple. I think you had one on your test, I feel like. It was a horizontal tangent. That A, B, and C, I think one of them was, anyway, it doesn't matter. Horizontal lines happen when slope is 0, yes? Do you, oh my gosh, yes. Robert doesn't know, he just has no idea. This kind of line has a slope of 0. This kind of line, undefined slope, right? So if I'm talking about a rational function, so my y, my initial y was x squared plus 3. Over, what was it over? 2x. If I want to know if this has any horizontal tangents, I need to find the derivative and set it equal to 0, right? But because it's a fraction, I have to think about what the top equaling 0 means and what the bottom equaling 0 means. So, we all agreed to know about horizontal and vertical. I need to look at slopes. Yes, to find slopes, I need to find a derivative. We already found the derivative. What was the simplified derivative here? It's minus. So we're using the derivative equation, right? Either one of these. Either one of these is fine. Yeah? Y'all okay? When the bottom equals 0, these are undefined slopes. Do you agree? This would tell me where I have vertical tangents, yes? Why is it important to know about vertical tangents? That means vertical tangents, I can't take a derivative there, right? Isn't that one of the things we talked about, like with that cube root graph that comes up?
Oh,
It's a vertical tangent, so you can't take the derivative. It's not differentiable there. So that's important to know. But I didn't ask you about vertical tangents. I asked you about horizontal tangents. The horizontal tangents are going to happen when this equals 0, but not the bottom because that would make it undefined. So I'm talking about where does x squared minus 3 equal 0? How do you make a fraction equal 0 without being undefined? The top has to be 0, right? Because 0 over anything is 0, but anything over 0 is undefined. I want to be in this scenario. So just set the top to 0. If the top equals 0, what does x equal? Square root of 3, but plus or minus square root of 3, right? I have two places of horizontal asymptotes here. Add 3 and take square root. Y'all okay? Well, the reason this happens, this is a rational function. Remember how rational functions, we've got these different pieces that happen on them and everything, so it happens at two different places. And what is that I have found, Robert? Where the horizontal tangent occurs on the graph, yes? So x equals square root of 3 and x equals negative 3 is where my function, my original function, has horizontal tangents. Yes. Now take it one step further. What do you know is happening on the original function at this point if there's a horizontal tangent there? What do we call that? How is the only way you can have a horizontal tangent? Think about it. Okay, parabola shape, you're on the right. Where on this parabola shape would I have a horizontal? The very bottom. What is that very bottom called? Mins or maxes, right? Where I'm changing direction. Those maxes or mins are where I'm going to have. That's going to be very, very important very, very soon, okay? So I'm starting to try to get you, do what? It is the vertex, but think max and min. Like think about if I had this, where is the tangent horizontal? It's going to happen here and here, right? Because that's where a tan line would be horizontal. As I come in, it's getting closer and closer to horizontal. What's wrong? Yeah. Well, hopefully you'll get.
I don't understand the vocabulary.
Yeah, I got one more thing to show you from this. I'm going to ask you two questions about this. My first question. No, don't distribute that. That would be a FOIL situation. Bless you. If I put the 1 in, I get 4 plus 1, which is 5, and 5 squared is 25. That's my slope. So your equation, don't worry, I did something wrong. That's why I erased it real quick and took it off the recording because I did something wrong when I did it. Well, I did too, don't worry about it. That's right. But now my question is, does this have any horizontal tangents? No. Madison says no. And what's at 0? So to know about horizontal tangents, I need to know, does the derivative ever equal 0? This is a big question. And the one that I'm looking at is the top equaling 0, right? Because if the bottom equals 0, that's a vertical tangent. I don't know about vertical. I want to know about the horizontal tangents, right? The horizontal line. So I want to know, where is the slope of the tan line equal to 0? Well, that would be where negative 16x equals 0, which we know happens at x equals 0. So I do, in fact, have a horizontal tangent, and that occurs when x equals 0. That's right. I plugged in 1. I took this equation, and I plugged in 1. Write the equation of the horizontal tan line. I did. So that occurs where? At x equals 0. The slope I know is 0 because that's what I made it, right? What point does that occur? That occurs at the point 0. Well, what's the y coordinate when x is 0? Plug it into the original equation. Because I keep asking you different things. Because you need a point and a slope. So the point happens on the original equation. It's the point of tangency. So y of 0, if you plug that in, I think you get 2.
So what is that?
That was where we found the equation of the tan line. That was part A at 1, 2. I'm on part B now. So plugging 0 into the derivative is not going to do you any good. You want to plug 0 into the original so that you have a point to work with. The derivative, this is the derivative. To know where it equals 0, you only worry about where the top equals 0. On the derivative? Yeah, there was. Not when you plugged in 1. That's when you evaluate it at a specific point. But yeah. If you have a fraction, it is, and you want to know where it equals 0, you say, okay, well, where does the top equal 0? Because that will make the fraction, because 0 divided by anything is 0. Yes?
Yeah.
So I set the top of the derivative equal to 0. Well, what's 0 divided by negative 16? I solved it for x.
I just don't get it. Why did you do that?
Because I wanted to know, where is there a horizontal tangent? At 0. That's where it starts, right? That's on the original function. That is correct. So the point 0, 2 would be a max or min on the original function. That is absolutely correct. Original function. Yes. So y minus 2 equals, I know the slope is 0, x minus 0. So this is just a horizontal line as it should be, yes? If it's a horizontal tangent, it's a horizontal line, so it makes sense that it's just y equals a number, right? Are y'all with me? It was painful.
I kind of don't understand why the derivative of y is 0 and the y is 2 and y is 6.
Okay, this is the x. I think you're just confused because the slope and the x are the same value. We can find more than just the first derivative. Well, it's the same thing. It's just finding. Find the first derivative of y here. Find the derivative. What's the derivative?
Add derivatives.
Yes, yes.
You like find derivatives.
This is first derivative. This is second derivative. Third. We can keep going on and on and on. It's a derivative of the derivative. All right, so what's the first derivative here? What else you want to do with that one? On when you simplify and stuff? I have you simplify most stuff just because on multiple choice you will have to have them simplified. All right, how about second derivative? Could you find another derivative? Could you find even another? 0. We would just kind of put a little 4 here once we get past 3. What's the derivative of a constant, Robert? I wasn't trying to yell at you.
Oh wait, I do have a question.
Yeah. Yeah. That's a 4 in parentheses. That's 3. 1, 2, 3, and then a 4. Well, you always what? Not always. Rational functions don't.
I like that. You should put, I like that one.
All right, let me give you your homework so then I can tell you what to expect on the quiz tomorrow. So what I'll do is I'll answer homework questions tomorrow, and then we'll do the quiz.